Welcome to the fourth video in this series. This video series is meant to be watched in order. Before watching this video, please make sure you have watched all the earlier ones first. You will find a link to the playlist for this series in the video notes. This video will show you how to process a payment to your smart contract. Neo N3 has uniform payment handling for all tokens on the N3 blockchain, and this feature has a very specific processing flow. First, you need to know something important about the big integer data type before we proceed. Smart contracts do not use floating point numbers because every floating point processor is slightly different. They are non-deterministic, so you could get a different arithmetic result between different processors when executing the same code. That cannot be allowed to happen, and that is why smart contracts only use integer arithmetic, which does not have that problem. But smart contracts do have to deal with fractions. To accomplish this, floating point values are multiplied by a very large number to create a very large integer value. The multiplier used varies between tokens. In the case of the Neo N3 gas token, that multiplier value is 10 to the 8th, or 100 million. You need to be aware that when your smart contract receives a number that represents a fraction, it will have been multiplied by a very large number to create the big integer value. You need to check the token smart contract to see what that value is. This graphic shows you the overall flow of a payment to a Neo N3 smart contract. Because Neo N3 has uniform payment handling for all tokens, payments have a specific pattern that I will describe in this video. By having uniform payment handling, you can use the same code to handle all token types, resulting in smart contract logic and code that is more consistent and easier to audit and maintain. Unlike ERC20 tokens on Ethereum, there are no special workarounds required to handle alternate tokens. You can accept Neo, Gas, or any other N3 token, all in the same smart contract method, as well as easily filtering out any tokens you wish to reject. Before we dive into the payment flow, let's take a look at an important JSON object. In a later video, we will see how payments in gas tokens are made from a dApps web page. You will see when and where an object like this is created. For now, it's enough to understand that this is an example of the custom object that contains the extra data or parameter information that is expected by the makeGame method, which is one of the payable methods in the Neo-Band Battles contract. I'll switch the JSON Object Editor into interactive mode. The interactive mode editor gives you a helpful form fill interface with field labels, so you can create invoke tests conveniently. Invoke tests and invoke files will be covered in an upcoming video. For now, it is a great way to show you the JSON object, but with a helpful field label next to each field. The field labels are taken from the target smart contract method. They are the parameter names for the makeGame method, and you will see this later when I show you the code for that method. The object contains the following fields. Nonce, which is the nonce value associated with the transaction that created the game. Entry fee gas, the amount of gas to pay to enter the game. Ban donate %, the percentage of the entry fee to donate to the bands after the house fee is deducted. Game creator address, the Neo N3 address of the game creator. Game creator video ID, the video ID of the video submitted by the game creator, since the game creator is also a player. And finally, video platform ID, the ID of the video platform the submitted video is hosted on. You will see in a moment how this object comes into play during the payment processing flow. For now, just remember that any entity that makes a payment to an N3 smart contract will usually provide a custom metadata object of their own during the invoke call that targets the method. Each object will have its own assortment of extra metadata or parameter info the target smart contract requires to process the payment. Here is the payment processing flow graphic again. The player makes a payment to the contract, usually via a web page that connects to a wallet app. This is when the custom data object is created by the wallet on behalf of the client-side app. The net result is that a data payload is created that contains the details for a transfer method call that will be executed via an invoke operation. However, the target address for that invoke call is not your smart contract. Instead, the Neo N3 gas contract is the target. So that contract's address is used with the invoke call, and it is that contract that has its transfer method called. If the player has enough funds to cover the amount of gas being transferred as part of the payment operation, the gas contract executes the transfer and then calls your smart contract's on NEP17 payment method. As a developer, you don't have the burden of checking the user's balance or making sure the user is authorized to send the payment. The gas contract performs those critical tasks for you. This also builds trust with the user because they don't have to worry about your smart contract stealing or losing their funds, whether due to malice or due to a bug in your smart contract. Your contract only receives the amount the player sent, nothing more. Your NEP17 payment method finishes the processing of the payment transaction by doing whatever operations are necessary as dictated by the nature of the transaction. It may be transferring ownership of an NFT, or creating a new game as in the case of Neo Band Battles, or something else depending on the nature of your application. In summary, a gas payment on Neo N3 is a relay operation that starts with the client-side app, who calls the gas contract's transfer method via an invoke operation, and then ends with your smart contract completing the transaction inside its onNEP17 payment method. Now let's go over the flowchart again, but this time showing you the C# code that is executed during the payment processing flow. We are back at the block in the payment processing flowchart that shows our smart contract's onNEP17 payment method after the gas contract has passed control to it. This is the onNEP17 payment method for the Neo Band Battle smart contract. This is the call signature for an onNEP17 payment implementation. The first parameter, named from, is the Neo N3 address for the sender of the payment. In this particular use case, it is the user that is creating the game, also known as the game host. The second parameter, named amount, is the amount of the payment. In this case, it will be the number of gas tokens sent to the contract. Note, unlike Neo tokens, gas tokens are divisible, so the amount could contain a fraction, upsized to a big integer value as we just learned. The third parameter, named data, is the custom data object described earlier. The contents of this object will change based on what your smart contract requires to facilitate a particular transaction. This line controls what tokens we are willing to accept. Because we only accept payments in gas tokens, we reject any tokens that come from a smart contract that is not the gas contract. We do this by verifying that the hash of the smart contract that called our NEP17 payment method matches that of the gas contract. Instead of having to use the actual hash value, you can use the gas constant as shown here. Note, much of what I will show you now is my personal style for handling NEP17 payments, and therefore is not an inherent part of programming Neo N3 smart contracts. Because I almost always end up having more than one payable transaction in my smart contracts, I always put the name of the method that handles a particular transaction in the very first slot of the data object array, and assign it to a variable named target method, as shown here. That line is followed by an if statement gauntlet. There is one if or else if line for each payment transaction type. In Neo Band Battles, there are currently only two payable transactions. The first is invoked when a user creates a new game. The second is invoked when players that are not the game creator enter a game. This is the if statement for the make game method, and here is the else if statement for the add player to game method. Each statement in the gauntlet dispatches the transaction to the correct smart contract method that handles the transaction. Each if statement does the same three simple tasks. 1. Make sure the expected number of parameters were sent for the requested method. 2. Unpack the parameters from the data object and assign them to variables while casting them to the correct type. If any other conversions are necessary, they are also done. 3. Dispatch the call to the correct smart contract method. In other words, the onNEP17 payment methods in my Neo N3 smart contracts act as a simple dispatcher. If you look at the names of the variables that receive the elements stored in the data object, you will see that they match the ones I showed you earlier in the interactive JSON editor the N3 plugin provides to help you create invoke files. This is the body of the else if statement that dispatches calls to the add player to game method. Again, it validates the number of parameters received in the data object, unpacks the data object to local variables while casting and converting them properly, and then dispatches the call. And finally, we throw an error if the target method that was requested is not one we recognize. In the previous video, I showed you step by step how to convert a Solidity function to a C# method, so I will not do that here. You can find a link to the video series playlist in the video notes if you want to review that video. But I do want to point out two things. First, the payable attribute is gone from the makeGame method because N3 contracts do not use that attribute. Second, all of my payable methods are marked private. This is because they are only called by the on-NEP17 payment method and never externally. Of course, every payable method also checks to see that the right party is calling it, but there is no harm in eliminating a potential attack surface every chance you get. To conclude this video, here is an important note about the neo-N3 check witness function. In Ethereum, to control access to a particular function in the smart contract, you frequently check the sender field in the transaction for a specific address value. However, you should not use that technique in your neo-N3 smart contracts. Instead, you should use the check witness function. In neo-N3, the transaction signing model is more powerful and more secure. N3 allows for multiple signers, each with their own specific permission scope that controls the execution context in which their signature can be used. The sender field in a transaction is simply the address of the account paying the fees for the transaction. So just checking the value of that field is not enough to take advantage of N3's advanced transaction signing model. Instead, you should always use the check witness method to validate access to contract functions. Join our free mailing list to be notified when the first interactive labs for the video series becomes available. Use the link found below in the video notes or visit neobandbattles.com. Neo.